Hey Airflow community, Airflow 3 is here and we are taking it on the road. Join the Astronomer Roadshow for an exclusive deep dive into the latest features, hands-on demos, and expert insights, all in a city near you. We'll be in London in May, New York City in June, Sydney in July, San Francisco in July, and Chicago in August. Don't miss your chance to connect with the Airflow community and get the inside scoop on what's next. Register now. The link is in the show notes.
Hello, everyone. Hello, everybody. I'm super excited to see you today. Welcome to the Data Flowcast. I'm your host, Mark Lamberti. And today I'm joined by Savin Goyal, co-founder and CTO at Outerbounds. And as you will see, he did a lot of things before creating his company. So I'm very excited for this podcast episode. How are you doing, Savin?
Pretty well. Thanks for having me here.
Yeah, it's a pleasure. So today we are going to discuss about machine learning. So I'm very excited about that because honestly, I don't know that much. So I will learn as you guys, you are listening to the episode. So we will discuss about machine learning. We will discuss about Metaflow as well, how to make your machine learning data pipelines more robust and easier to create and manage. And also, obviously, we will see how to connect Metaflow with Airflow. And we will start by having a bit of the background of Savin, because again, he has a really interesting background. So without further ado, let's begin. So Savin, can you actually tell us more about yourself? Like, what did you do before starting Outerbounds?
Yeah, so I think, in my career, I've spent sort of like a whole bunch of time building out infrastructure for data engineering, machine learning, and now sort of like AI. And prior to Outerbounds, I was at Netflix for close to 6 years, building out their capabilities around the infrastructure stack for, let's say, many of the things that you might enjoy watching it with Netflix. So for example, let's say if you think about Netflix recommendations or how Netflix figures out what content it should be provisioning on its service, there's a significant amount of data engineering, machine learning, AI that sort of like goes in. And then the open question there always is that, okay, what is that infrastructure stack? So I spent sort of like a good number of years building that out there. Prior to that, I was at LinkedIn trying to sort of like, solve similar problems, but more in a social network context or a professional network context.
Okay. Any reason why you were on the infra side and not like a data engineer? Like, why did you decide to go on the infrastructure side?
Yeah, no, I think it's sort of like, more of a happenstance, I would say. So I remember my very first job, we had basically a team of data scientists and a team of software engineers. And this company, they were basically sort of like, building out ad tech, like click-through prediction models, click-through prediction models. And when I started, I was quite curious to do machine learning, AI all by myself. And I started on the data science team, as it used to be known then. And very quickly, I realized that I just did not have the patience to do a whole bunch of experiments and heuristics that are needed to sort of like, really, at the end of the day, gain, let's say, a few basis points of prediction accuracy. I mean, very impactful work, but it just requires a very different mindset. And I ended up being that individual who knew a little bit of software engineering, a little bit of data science. So I ended up becoming that go-between person that was helping out the data science team with all the engineering work, ensuring that, all the models are productionized and sort of like kept up to date, all the infrastructure that would be needed. And this is like, gosh, like almost a decade ago. And interestingly, the keyword ML engineer did not exist at that time. So people had a really hard time figuring out that, okay, like, what do they call me, right? Saying, am I a data scientist? Am I an engineer? So that's how I got started. And there were very few people at that time who were actually truly focused on building infrastructure to enable data engineers, data scientists to be sort of like a lot more productive. And honestly, I very much liked that work because it also helped me to be very horizontal, because at any given point in time, I could vicariously focus on many different problems, right? I mean, working with teams that were, let's say, doing fraud detection versus recommendation systems versus, let's say, optimizing marketing budgets or doing NLP. I mean, these are all very interesting problems. I had the liberty of not really sort of like, focusing myself too much on the experimentation side of the house, but still sort of like, have my fingers dipped into sort of like all of these super exciting areas. So, and yeah, I mean, it's been sort of like now more than a decade, and I very much enjoy the role that I ended up sort of like, choosing for myself by like sheer happenstance.
That's awesome, because I share actually a bit of a similar story. I started as a data scientist, and then I mean, it happened that I was better as a data engineer. I just had this software engineering background as well, and I realized that data engineering for me was better than data scientist. So you never know exactly what happens, but at some point you just follow your guts, and you feel that you are better in this position than the previous one that you thought would be better. But so this is great. I guess like one question to you. So when you were at Netflix, can you tell us more a bit about like maybe the stack that you were using, and also a bit of what exactly you were doing, what kind of use cases, like what were you managing in the on the infra side?
Yeah, yeah. So of course, if you think about, let's say, a company like Netflix, they have done machine learning, AI for like decades now. Back in the day, Netflix Price was sort of like, really popular, sort of like, one of the very first publicly available corporate data set that many labs could sort of like use to actually try out net new ideas in the machine learning space. And then, of course, their recommendation systems have been also really, really famous and popular. Now, the interesting thing is that, if you were, let's say, doing ML in, let's say, late 2000s, early 2010s, then it's very likely that your machine learning stack was an extension of your big data stack, which in many ways was sort of like, very much Hadoop or Spark oriented.
Yeah.
And in around sort of like mid 2010s, the machine learning universe basically sort of like moved away from Java onto a more sort of like Pythonic ecosystem, as sort of like TensorFlow, PyTorch, and sort of like many other open source projects sort of like, started to gain popularity. And at Netflix, we were at sort of like a similar crossroads as well. So this is sort of like, circa like 2016, 2017, where we had a very sophisticated recommendation system. But then Netflix's appetite to invest in ML and AI across like other parts of the business was also growing immensely. You can imagine Netflix is spending, tens of billions of dollars any given year
Yeah.
on licensing or producing content. So it needs to make a decision in terms of what content should be on its service, right? There are like hundreds of millions of Netflix subscribers. How do you basically more efficiently stream content onto the viewers' devices, whether it's sort of like, televisions or cell phones or iPads? How do you, let's say, experiment with pricing? How do you fight fraud? Many interesting data problems that sort of like, come in. And an interesting question is that, okay, how do you optimize these? And these are then sort of like problems that are rooted in data. These are problems rooted in incredible amount of compute, rooted in machine learning, statistics. And then the question was that, okay, can the stack that has served us so well for the recommendation universe carry us forward for many of these problems as well? And the answer was unfortunately not a resounding yes. It was
Okay.
sort of like a maybe, or sort of like, maybe a no, because it just wasn't sort of like a Pythonic ecosystem that, let's say, a lot of net new talent that was coming into Netflix was exposed to. So we then decided to sort of like take a fresh look at what that modern ML infrastructure would sort of like look like. What are the key components, ingredients for it? What already exists within an organization? What can we sort of like, let's say, adopt from the outside, either sort of like buy a commercial solution, adopt an open source product, and what can be built internally? And I think that was a very pragmatic choice, because many times, when it comes to modernization, there's sort of like a knee-jerk reaction that let's sort of like, just replace everything that we have built so far, and not really sort of like figure out like, what are some of the good things that can sort of like, still be part of the new world. And that's the exercise that we sort of like started to take. And our understanding was that there are certain key components that are necessary both for your data engineering ecosystem, for your ML ecosystem, as well as for your AI ecosystem. And the relative weight that you provide to each of those layers may sort of like vary somewhat, but at the end of the day, it's sort of like, is a good mental model to sort of like, get the world through. And for us, that was basically, you need sort of like a great data platform to manage, let's say, your data assets, let's say your machine learning outcomes, whether it's like models, artifacts, your embeddings and whatnot. You need a compute platform. And now the shape of this compute platform can look very different depending on what you're doing. So for example, let's say if you're doing data engineering workload, then maybe sort of like, having a homogeneous compute infrastructure might be great for you because you're really sort of like optimizing for CPU cores and sort of like memory. But then if you're doing anything related to machine learning, then heterogeneity becomes sort of like, a first class citizen where you want to sort of like actually experiment with a lot of exotic hardware to sort of like eke out maximum performance. Again, like with AI, of course, we all know sort of like how important GPUs have sort of like become. Um, then there is this notion of orchestration that sort of like,
Yeah.
again becomes sort of like really important that, okay, now that you have all of these data assets in place, now you have access to, let's say, this compute ecosystem. How do you actually author your compute? And when I say orchestration, of course, like there's the workflow orchestration universe, but if you take sort of like a very conceptual worldview, then it's more about like, okay, I have a workload. I need to be able to author that workload very quickly. Let's say as a data engineer or a data scientist, be able to experiment and ideate through a whole bunch of different hypotheses. And then the hypotheses that are sort of like, more like leading to sort of like, more confident results. How do I productionize those and make those part of my production system? Right. And then workflow orchestrator sort of like, end up making sort of like a great sort of like forward progress here in this space. And the interesting thing again is that with data engineering workloads, you have workloads of a specific nature. With machine learning workloads, the workloads are still sort of like very similar as far as orchestration is concerned, but then you can have workloads that may run for a really long duration. For example, that's, spanning, let's say, weeks and months, or you can have workloads that are very fat in nature because you want to do hyperparameter tuning. So you want to run like multiple jobs in parallel at any given point in time and so on and so forth. But still sort of like that basic run top sort on my dependency graph and run that reliably is sort of like, very much pertinent. And then as you sort of like, start going up the value chain, up the tool stack, then there are certain sort of like ML specific components that come in. One bigger difference between, let's say, data engineering and machine learning workloads that sort of like come up, and of course, it's sort of like also very debatable, is that ML workloads by their very nature are very experimental in nature. So you have multiple versions of it and you want to be able to move from one version to the other version very quickly. Then another concern that sort of like comes up is that how do you do fault detection for your machine learning workloads? Because many times those faults could be statistical in nature, right? So then those things come into picture. And then there's this question of like, okay, what does the business logic actually looks like? Because of course, the business logic is also very different in many ways. Few things that are common, which are, let's say, around dependency hell. Everybody sort of like, is familiar with that, if you rely not only on your code, but code written by somebody else, how do you experiment through that? How do you sort of like, make that reliable? That problem becomes a little bit more non-trivial in, let's say, machine learning universe, because not only you have Pythonic dependencies, but you also have like other non-Pythonic dependencies that are also sort of like as critical, at least, let's say, your GPU drivers and sort of like other packages that you might be relying on. And now, if you look at, let's say, this entire tech stack, right, like each of these problems are really massive problems that no one single team can solve by themselves, right? And we did have the luxury at Netflix that we had a data platform team, we had a compute platform team, we had an orchestration team. So different teams solving sort of like, each of these problems. But now, if you think about, let's say, a data scientist, an ML engineer, they are coming more from a universe of, let's say, quantitative sciences, right? Like they have, let's say, gone to school to study statistics, to study math, to study econometrics. And this is a good amount of infrastructure that anybody has to contend with. And now the big sort of like productivity, sort of like the thing that sort of like hampering productivity in the organization is that how do you actually provision the stack in the most easy and straightforward manner for your data science team, as well as how do you provide a user experience such that they don't have to worry about the nitty-gritties of, let's say, how do you spin up GPUs? How do you optimize your GPU instances? How do you move, let's say, large volume of data from your data warehouse to these compute instances or from one compute instance to the other? How do you make sure that people don't have to think about experimentation day in and day out all by themselves, that, the things that I'm doing are be sort of like reproducible by default so that I have a chance of, let's say, recovering from failures or building on top of my peers' work? Or do I have to now sort of like manage Docker files by hand? I mean, these are all the 1,000 different paper cuts that basically are the difference between a data science team being able to ship or experiment with thousands of models in a week versus, let's say, a team of data scientists who are experimenting with a handful of models in a quarter.
Mhm.
And you can imagine sort of like going from few models in a quarter to thousands of models in a week. That's a step change improvement
Yeah.
in productivity. And especially on the data science side of the house, what usually ends up happening is that your first model is usually a crappy model. Your
Yeah.
second version is going to be slightly better, and then the third version is going to be even more sort of like, better, and so on and so forth. So the actual gains with ML comes from the ability to be able to experiment effectively. And that's basically what we were optimizing for. And that was basically sort of like, what my team was tasked with. And we decided that, okay, like a whole bunch of tooling that Netflix has built over the past very many years, that's an asset. And can we basically sort of like build a layer around it that basically then provides an opinionated view around how data scientists should be thinking about, let's say, data platform, compute platform, orchestration, versioning, and so on and so forth. And that's basically was the Metaflow project.
I must say that I didn't realize how many challenges you can have when you actually want to run machine learning pipelines. So before this conversation, so that's actually many challenges that maybe we don't realize. And to your point, like obviously at Netflix, you had this luxury of having a team for the computing stuff, a team for the orchestrating stuff, which is definitely not a luxury that many companies have. So I guess like one quick question before talking about Metaflow, because you just introduced it. What was the orchestration system that Netflix was using? Was it Airflow? Or was it a built-in
Yeah.
in-house?
So I think it's sort of like very common in like large companies that you'll have like scores of orchestration systems. So I remember that, so I left Netflix 4 years ago, and
Mhm.
even back then we had like at least like five major orchestration systems. So data
Wow.
engineering universe was using one, then many of the
Okay.
software engineering teams were using yet another one. For video encoding, we had sort of like yet another workflow orchestration system. And usually sort of like what ends up happening is that depending on the problem that you are trying to solve, I mean, workflow orchestration systems, just like databases, right? Like
Mm,
each optimizes for a very different outcome. So
yeah.
depending on what your perspective is, what your philosophy is, you may sort of like end up choosing one or the other. The orchestration system that Netflix uses today is called Maestro, and I think very
Yeah.
recently they had done a blog post around it as well.
I saw that. Yeah. Okay. Oh, actually, you mentioned something very interesting. So you don't think that we can have? I mean, you don't think that we can have one orchestrator for everything? Do you think that you should have like one orchestrator for some specific things
I
and then
mean,
another? Like, what do you think?
I do feel that you can have one orchestrator for many things,
Okay.
right? Like maybe not all, because again, the shape of
Yeah,
the
of
problem
course.
is sort of like
Yeah.
very different, but it's also sort of like, not supposed to be a cop out that for every single small little detail,
Yeah.
like,
Yeah.
that's
Yeah.
different from, let's say, your current use case, sort of like spin up a brand new sort of like orchestrator out there. And we very strongly sort of like feel and believe in that philosophy, because I mean, at the end of the day, you can also think about, let's say, an orchestrator as a mechanism or as an interface where multiple different teams collaborate, right?
Mm,
Because if you are, let's say, in any kind of medium-sized team, then what's happening is that a lot of work or a lot of effort is spent around change management. That, let's say, one team is producing something, it's a model, it's a data artifact, it's some library or something, and then another team has to consume that, right? So depending on what you're doing, it's very likely that, let's say, your orchestrator can be that sort of like change management mechanism for you. So imagine, there's a team of data engineers that are writing some workload, and that workload generates some data set. Let's say, it generates data set for everything that customers have viewed, let's say, in the last 24 hours. And then that data set is picked up by some ML team to generate, let's say, LTV predictions. And now there has to be some signaling mechanism that, a data set has been generated, and now that data set is fit for consumption, and then sort of like a further downstream process to start. And orchestration systems can be sort of like a good mechanism to
mhm.
actually sort of like, provide that interface barrier between sort of like different teams. And now the interesting thing that at times comes in is that these two teams could be sort of like coming from a variety of different universes as well, right? Like it could be a data engineering team and a software engineering team, or a software engineering team and an ML team, or a data engineering team and a security team, and so on and so forth. And that's the perspective that we ended up taking. And also, there was also one other thing that we saw where most companies, they also have an evolution around how
Yep.
they think about workflow orchestration. And we also wanted to make sure that our customers, let's say our data scientists, were in many ways insulated from many of those sort of like movements of
Okay.
the underlying infrastructure, right? Because you can imagine it, and it doesn't necessarily just apply to your orchestration, right? Like, I mean, the world is constantly moving. So your orchestration capabilities are moving, your compute capabilities are moving, the data warehouses, databases you're introducing, everything is moving. And the one thing that we really wanted to provision for our data scientists was that if they're happy with the workload that they have authored, can we provide, let's say, stability as a service such that we are on the hook for providing stable APIs, stable interfaces, even though, let's say, behind the scenes, if let's say you're using Airflow and Airflow moves from 1.x to 2.x, then our compilation logic changes.
Okay.
But then as a data scientist, you don't have to come in and be like, oh my gosh, now I need to re-implement all of my work, which can be really expensive and risky for any organization, right? And or let's say, if you're using Kubernetes as your compute system, and for whatever reason your Kubernetes APIs change, or you're using some sort of like data warehouse, and now sort of like, something has to change. If we can minimize the odds that a data science team or a data engineering team has to come back and re-implement their workloads, that's a big, big productivity
Yeah.
boost for us as well, because then you're constantly just like moving forward rather than sort of like, hey, here's the project that I worked 2 years ago. And now I need to come back and so re-implement the thing and avoid the risk that something sort of like breaks in the process. No organization should ever be in
Yeah.
that situation either.
Yeah, it would be a nightmare for sure.
Exactly.
So you mentioned that I mean, obviously now we know that there are definitely many challenges for running machine learning workloads, and you also mentioned that this additional layer on top of the stack, to your point, to abstract all the complexities that you might have when you want to run machine learning workloads, and you talked about Metaflow. So can you tell us more about this? Like what exactly is Metaflow? Why should I use it, and also what's the point between Metaflow and Airflow?
Yeah, it's excellent question. So basically, Metaflow's prime focus is to solve sort of like all the problems that I just sort of like called out in sort of like, all the stack. And then, of course, sort of like with a key focus on the fact that much of the complexity, of course, each individual layers by themselves are complex, but then the interaction between these two layers is also incredibly important, right? Like if let's say you're dealing with, let's say, massive data sets, how do you make sure that data transport is optimized between your data warehouse to your compute instances? Or like one of the big issues that sort of like ends up biting people anytime they have to build any kind of production workloads is how do they iterate their way? What is the development story for authoring these workloads, right? So those are all the things that we are basically sort of like trying to solve. People are curious. I mean, it's an open source project, so if you go to github.com/netflix/metaflow, you can find sort of like all the code and examples there. On the orchestration side of the house specifically, when we, let's say, think about Airflow versus Metaflow, I mean, the naming was sort of like a bit unfortunate with sort of like flow in both the places. So a lot of people sort of like, think about it more in terms of like,
Yeah.
hey, should I be considering, or like, should I even be entertaining this question of Metaflow versus Airflow? I guess the right question always is Metaflow and Airflow. And we have like multiple companies, I think Ramp and many others who sort of like, follow a very similar sort of like pattern as well. Where Airflow is a great tool where all your data engineers are sort of like operating and they're writing your data engineering pipelines to sort of like, manifest these data products in many ways. And now if you take, let's say, take the perspective of a data scientist, what the data scientist really wants to do is that, let's say, from within their Jupyter notebook or whatever their favorite IDE is, they want to write some code to be able to access these data sets, perform some compute on top of this. And this compute in many ways can also sort of like look like a workflow in many ways, and iterate through multiple versions of it very, very quickly. And then once they are happy, then they want to basically sort of like take this workflow and make this part of, let's say, a workflow orchestrator. And when I say a workflow orchestrator, you can basically sort of like think about a workflow orchestrator in a very crude terms as I have my dependency graph of jobs, And
Mm-hmm.
can something very reliably based on some signal execute that dependency graph? But then what is happening within each of the job is totally up to me, right?
Okay.
And now, of course, you cannot imagine, let's say, a data scientist coming in and very willingly wanting to spend a whole lot of time, let's say, figuring out, like, hey, what should my Kubernetes pod look like? How do I pass data from, let's say, one step to the other? How do I think about, let's say, getting the right version of GPU drivers? How do I do things in the most sort of like cost-effective way while having sort of like access to all sorts of visualization charts, data science related metrics that I need? But once you are able to do everything, then one question that sort of like, is always open is that, hey, can we somehow run this entire new workload that we have generated simply on top of Airflow? Because it already exists. There's a
Yeah.
team at an organization that is on the hook for maintaining and managing the uptime of that product. And
Mm-hmm.
if you just like piggyback on top of it, it's sort of like, more leverage that you're sort of like
Yeah.
gaining. And that's basically one of the features that sort of like Metaflow provides, where you can author your workload. Once you're happy with your workload, then you can compile that workload into an Airflow DAG, submit it to Airflow. And now this workload will run as a bona fide Airflow DAG. All the features, that everything that you have access to in Airflow, you have access to that. But then at the same time, you have access to all the Metaflow functionality that is all geared towards sort of like, running high scale ML AI workloads in sort of like the most simplistic manner as possible. So that's basically sort of like is the primary mechanism with which people sort of like actually end up using Metaflow in open source.
So I guess like just to better understand how it works. So I can use Metaflow to create my ML workload, my ML workflow. Am I gonna create the tasks directly in Metaflow and then I will compile those tasks into an Airflow DAG, or like how does it work exactly?
Yeah, I can. So basically, as of today, you can just do pip install Metaflow,
Okay.
not deploy any infrastructure related to Metaflow. Of course, if you do that, then you get sort of like additional functionalities as well. And
Mm-hmm.
then you can start writing pure Python. And you can have functions. And then if you, let's say, annotate your function with a decorator called step, then it becomes a
Okay.
node in your graph. And then we have this self.next functionality that defines edges in your graph. And then Metaflow will
Okay.
basically, you can take this workload and you can run this locally without any sort of like external dependencies or anything, right? And Metaflow will basically provide you all the bells and whistles around versioning, dependency management, compute management, everything that you would sort of like need from a data science ML perspective. Now,
Okay.
what happens is that as you're running this workload is running locally on your laptop. And one of the biggest challenges that people run into is that, hey, I may not have GPUs on my laptop. I may not have sufficient memory on my laptop, right? And you can drop additional decorators where we'll take just those functions and run it in the cloud or sort of like, wherever your compute resources are located transparently for you. And the experience would be as if, let's say, somebody just like came in and attached a bunch of GPUs or extra RAM to your laptop.
Mm-hmm.
But still, everything is getting managed and controlled by your laptop. So we run sort of like a Python process that is basically doing this top sort for you and sort of like managing everything for you. There isn't any centralized Metaflow service or any such thing.
Mm-hmm.
And what that means is that if you shut your laptop, then your workload will get killed, right?
Okay.
And then the big question that comes up is that, okay, now if I need durable execution, how do I sort of like, get there? And
Mm-hmm.
one idea or like one option that we could have had is that, okay, we could have gone out and implemented our own workflow orchestrator. But then
Okay.
the reality is that most companies already have a workflow orchestrator even before the first data scientist is hired, because you have data engineers there already, right? And the goal was that, okay, given that there's already a workflow orchestrator, rather than reinventing the world, we can just like compile everything down into a language that the workflow orchestrator can understand, right? In
Mm-hmm.
this case, we basically, then if you decide that, okay, well, like my workload is working as I expect, now I need to run this on an external server. You can then, with just one single command, you can generate an Airflow DAG out of it, and you can deploy it to your Airflow server. And now it's a bona fide Airflow DAG. You get sort of like all the benefits of Airflow, but then you
Mm-hmm.
also get all the benefits of Metaflow at the same time.
That's awesome. And I guess like because I'm not gonna lie, I also checked the
Mhm.
documentation. There is a Metaflow UI. Am I gonna get access
Yes,
to the Metaflow UI as well? Like,
exactly.
should I use the Airflow UI and the Metaflow UI? I mean, they serve different purposes. Like, how do they work together?
Exactly. So you can imagine sort of like the Airflow UI will capture all your workloads that are deployed to Airflow. The
Mhm.
Metaflow UI is basically capturing all the workloads that are running through Metaflow, whether you're running it locally or through Airflow. Now,
Okay.
Airflow is good at, let's say, providing you visibility into the pipeline and sort of like all the operational monitoring and everything. But then on the open source Metaflow UI will basically then sort of like help you understand in depth what is happening inside the workload through taking sort of like more of a
I
ML
see.
first approach versus the Airflow UI will take sort of like more a pipeline first approach. So that's the differentiation. So the Metaflow UI is not sort of like suppose served as a replacement for the Airflow UI, but it's more like, okay, you get sort of like your top
Mm.
level pipeline view. But now if you want to go deeper and get access to, let's say, more Metaflow bits, then you get access to the Metaflow UI. And the way we sort of like stitch up the Metaflow UI is that you can also move between these two UIs. So within the Metaflow UI, you'll have sort of like all the links to your Airflow UI. And then within the Airflow UI, will sort of like attach all the metadata so that you can get to your Metaflow UI as well. Because many times you can imagine maybe sort of like, you have set up PagerDuty alerts on your Airflow UI. So if
Mhm.
a pipeline fails, it sort of like, generates a page for you. So you sort
Yep.
of like, get to the Airflow UI. From the Airflow UI, now you want to sort of like get a deeper view into what's happening in the Metaflow land. So you can get into the Metaflow UI as well if you want, as well as sort of like vice versa. And then the other thing that we also look for here is that you can imagine failures can happen quite often. Many times these
Okay.
failures are statistical in nature, and these
Yeah.
failures can oftentimes result in cascading failures too, because
Yeah.
your workload fails, your pipeline fails, and then other downstream teams are blocked.
Yeah.
So how quickly you're able to recuperate is really important. And within Metaflow, what we end up doing is that we capture your entire state. We capture all the intermediate variables, your third-party dependencies, everything, so that you get sort of like a very strong guarantee around reproducibility, where with one single command, you're able to replay that compute step by step so that you can actually try to reproduce that exact same failures. Because one of the big struggle that we saw happen quite often with machine learning workloads was that a failure will happen. You know that a failure has happened, but replicating that failure is going to take so much time and it's going to
Mm.
be so painful that many times people just give up and they're like, okay, let's sort of like, figure out some other sort of like strategy. And during that entire duration, all the downstream teams are still waiting. So
Okay.
for us, the goal was that, okay, how can we also sort of like reduce the time to recovery? And to reduce the time to recovery, the time to reproducing the bug is really, really extremely important. And that's where sort of like, the mechanism with which sort of like, Metaflow is able to capture everything that is happening
Mhm.
within the workload, sort of like becomes really useful for us.
Like the more we are talking about Metaflow, the more I want to try it.
Yeah.
Honestly, like I mean, this conversation is super interesting. I definitely want to get my hands on it. I guess like actually, speaking of getting my hands on it, I mean, obviously it is open source, so anybody can install and contribute to Metaflow, which is great. But let's say I just want to try it on the cloud. Can I do that? Is there any way
Yeah.
to do it? Okay.
Yes, yes, yes. So, and of course, you can imagine sort of like, Metaflow is a cloud native solution. And many times when people are, let's say, placing a bet on, let's say, a workflow orchestrator like Airflow or a data
Mhm.
science solution like Metaflow, then you do need to sort of like build significant confidence in the solution before sort of like going forward with it. So we offer Metaflow sandboxes. So if you go to our open source website, metaflow.org, you'll find a link to sandboxes, which
Okay.
will basically sort of like provide you a pre-provisioned environment with compute and an S3 bucket and everything. So that you can actually try out sort of like, our entire open source examples and sort of like, bring in your own examples to basically figure out, is this something that really truly sort of like works for you, works at sort of like, the scale that you're looking for. And if it does, then we do have all the deployment templates available in open source as well. Then you can sort of like use to deploy Metaflow internally in your organization.
Okay. And I guess like so you've created your company Outerbounds. Is it using, I guess it is using Metaflow, right?
Yes, yes. So we basically provide a managed service around Metaflow because you can imagine, like one of the big advantage that we had at Netflix was that we were standing on the shoulders of the giants. So there was a
Yeah.
compute platform, there's a data platform, and many other
Yeah.
things, right? And as it so happens, many companies um, may not, should not invest all by themselves in sort of
Mm.
like these solutions because this, at the end of the day, is undifferentiated heavy lifting. Just because you build a great internal compute platform doesn't necessarily mean that the business that the company is involved in that sort of like the odds of succeeding in that sort of like also goes up. An example is Netflix doesn't run its own data centers, sort of like trusts AWS to do the right thing. And
Mm.
many other companies also make the similar decision that, hey, we need ML capabilities. And we want to sort of like, adopt a product that basically provides these ML capabilities on top of our existing stack, as well as filling in the existing gaps that we may have, if any. And that's where Outerbounds comes in.
Okay, well, I'm definitely gonna try that out. Okay, I guess like one last question, which is a bit different, but I would love to have your perspective on that. What would you say to someone that wants to become a data engineer or a ML engineer, maybe? With this world of AI, like what will be your recommendations? Like if I want to become a ML engineer or a data engineer, and when I'm reading everything online, AI is going to replace my job and so on, like what would be your recommendations? Like what would you say to someone that wants to?
So, in my career, the most successful data scientists, ML engineers, AI researchers, data engineers weren't the ones who were exceptionally skilled at technology. They weren't.
Mhm.
The most successful ones were the ones who really internalized what it took to make the business win, right? What is the business problem that they are sort of like, tasked to solve? I mean, I've seen sort of like, plenty of scenarios where people would get caught up on, let's say, the latest real-time streaming technology and whatnot, only to realize that, let's say, the dashboard or let's say the data that's needed. I mean, it gets looked at, very important dashboard, very important data sets, but it gets looked at, let's say, once a week or something. And it's like the
Yeah.
accuracy and being able to figure out how to sort of like get to the outcome quite as fast as possible. That's the most important thing that sort of like makes a difference. And trust me, I mean, AI is nowhere close to doing any of that. So I would say that the key to success is really understanding what is the business problem at hand, really internalizing what is really needed, because most organizations, they do not do well with internal communications. So you have to really truly understand what is it that's really needed, dig much, much deeper, and that's where sort of like the real solutions lie. And no AI is going to be capable of doing that. I mean, if let's say we get to that universe, we'll be happy in many other regards as well. So I'm not too worried about AI coming in. Of course, it has definitely, like, if you think about AI as a very smart autocomplete, it has
Mhm.
definitely made everybody's lives easier.
Mm.
But then it also provides you a lot more time and energy to focus on what are the true expectations of the organization from you. And that's basically what is going to really take you high out.
I love that. I love that. Thank you so much. Super, super, super interesting. Okay, well, Savin, that's it. That's it for today. Thank you so much for joining. I guess one last question: what is the best way for folks to get in touch with you if they want to learn more about Metaflow or your company, or like, what is the best way?
Yeah. Please feel free to connect with me on LinkedIn. That's sort of like, is always the easiest way to reach out. And we have an open source Slack community as well. So chat.metaflow.org. And if you're interested in, talking about data orchestration and other things, happy to sort of like have a chat. And of course, I'm also available on the Airflow Slack. So if you're already on the Airflow Slack, yeah, just ping me, and happy to sort of like engage there as well.
Awesome. Well, thank you so much. Have a wonderful day and take care. See you for another episode.
Yeah, thank you. Thanks for having me.